Good afternoon, good afternoon, good afternoon. Why does my screen look like it's frozen? I'm having some challenges with Zoom. So, yeah, it's unresponsive at the moment. There we go. Everybody stop freezing. Okay. All right, my Zoom just keeps locking up on me. Good afternoon. Good afternoon. All right. We are looking at human population dynamics today. Most of you have finished with your calculations, and that was fairly simple. And let's get Sean here. He's not here yet. Like I said, I don't know what's happening with my Zoom. It just keeps freezing up, especially when I go to share, because I'm trying to share now. And it just spins round and round. Lets me know that it's going to get there eventually. But while mine is trying to share, you can go into Canvas and look up 3.8 human population dynamics. While it's trying to do that, I'll wait for a few more people to come in. Missing quite a few at the moment. Like I said, I am trying to share. My share screen is just spinning round and round. All right, we're getting there. Yeah, finally. All right, so we are in Canvas. To come in and for my Zoom to get itself together. A couple of people in the waiting room, trying to let them in. Like I said, all day long I've been good until I try to share. Once I start sharing, then it starts freezing up on me. think I got my folks out of the waiting room. I think it stopped freezing. All right, because Sean, I fixed that. That I had 10 on the brain, and that's why I did that. I apologize. Didn't mean to put you into shock. You good? All righty. Let's see. Most people are here, so we'll go ahead and get started. So again, most of you have already completed your calculations, and that was pretty good. Again, they provide, when you're doing this on the test in the AP classroom, they do provide a calculator within the system, so you can use those. And it's one of those formulas that you just have to I keep a formula page when I'm taking notes of that nature. So there's going to be quite a few formulas with this section. So I would start a formula notebook or a page that a cheat sheet as we start moving towards the exam. Start organizing your thoughts. Those of you who are taking the exam, start organizing your self so that you have materials at your fingertips and you're not going to be all over the place looking for information. So having formulas handy would be nice. Sometimes they give you the formula at the beginning and sometimes they don't. All right, so we are looking at dynamics, population dynamics. And these are factors that affect population size. So we check in with our friend, Mr. Smeeds.
My name is Dustin Watson, and this is Longacre Farm.
Hey everybody, it's Mr. Smeeds, and today we'll be talking about topic 3.8, which is human population dynamics. So, as you know, all ecosystems have limited resources, and so all populations must hit a carrying capacity at some point. And this was the basis for a theory put forth by English economist Thomas Malthus in 1798. As you can see in this graph, Malthus noticed that human population was growing exponentially, or at its biotic potential. Meanwhile, our food resources were only increasing in a linear fashion. So he predicted that controls like famine and resulting wars would lead to events that became known as Malthusian catastrophes. And he predicted that these would limit human population growth or impose a carrying capacity for humans. What we'll talk about throughout this video is the factors that Malthus didn't account for, such as technological advancement that would alter food supply. So our objective for today is to be able to explain how human populations experience growth and decline. And in order to do this, we need to know about all the factors that increase and decrease human populations, primarily birth rates and death rates. We also need to know that there are global limits to the human population, primarily arable or farmable land limits. And finally, we'll learn a simple formula called the Rule of 70, which can be used to predict how long it takes a population to double in size. Our suggested science skill for the day is describing environmental problems. So as I mentioned in the intro, Thomas Malthus theorized that because population was growing exponentially, but food growth was linear, sooner or later we would have to run out of food to feed everyone, which would impose a carrying capacity on Earth's human population. So one of the flaws of Malthusian theory, though, is that it failed to account for the idea that technological advancements could increase our food supply. And the best example of this was the discovery of the Haber-Bosch process for fixing nitrogen into ammonia in 1918. So this led to the creation of synthetic nitrogen-containing fertilizers, which would dramatically increase the productivity of our agricultural lands and therefore increase our food supply in a way that Malthus just never could have predicted. So as we can see here, that while the growth of the food supply in the UK was relatively linear for about 600 years, there was a dramatic and exponential increase in the 20th century following the invention of synthetic fertilizers. So this is what accounts for the dramatic increase in food production that Malthus failed to account for. However, the most prominent social biologist of today, E.O. Wilson, has concluded that the Earth will still experience a carrying capacity based on the limits of our farmland, and he and many other leading social biologists have predicted this number will be around 10 billion. So this kind of begs the question, will we find a way to dramatically increase Earth's food supply again? And we don't really know, but this illustrates an important apes concept, which is that predicting Earth's carrying capacity for humans is difficult because future technology can alter resource availability in a way that just isn't possible for other species on Earth. So because most countries on Earth are experiencing population growth and population size has a really significant impact on the environment, it's a really important ape skill to be able to calculate the growth rate for a human population. We can do this using two human population measures called crude birth rate and crude death rate. And these are simply the number of births and deaths in a population per 1,000 people. So we can calculate the growth rate by subtracting the death rate from the birth rate and then dividing that number by 10, since CBR and CDR are both out of 1,000, but growth is always expressed as a percent, which literally means per 100. In this example, we have a global CBR of 20 and a global CDR of 8. So if we subtract 8 from 20, we get 12. When we divide 12 by 10, we get 1.2, which means Earth's global population grows by 1.2%.
Should we continue putting
That's a
engineering
weird
resources?
place for a
You should
commercial.
sunset it.
How do you?
Survey Monkey.
Each year.
They make it so hard to skip these things.
And remember, we always express this growth rate as a percentage. Now we have a really simple formula to estimate the time it will take for a population size to double, and we call this the rule of 70. So all you need to do to determine the time it will take a population to double is divide 70 by the growth rate of the population. So using this example of a 1.2% global growth rate, we would estimate then that Earth's population will double in 58.3 years. So all we needed to do there was divide 70 by 1.2. So here's a practice problem that involves both growth rate and doubling time. See if you can calculate the growth rate for a country with a CDR of 9 and a CBR of 18.
Okay, I'm going to pause it right there and take a minute and see if you can do that before you give the answer. So let's go back just a minute and look at the formula. All right, so write down the formula. And then we come back to his question.
Time. See if you can calculate the growth rate for a country with a CDR of 9 and a CBR of 18. Then use that population growth rate to figure out how long it would take this population to double. So you can pause the video now, work this out, and then when you unpause, the answer will be on the screen.
Okay, we'll pause it again because he's added a question. I'm gonna give you another minute. I know some of you are not practicing, so practice, practice, practice makes perfect.
Now we'll talk about
Oops,
some factors that affect human population growth.
hold on.
And this is a bit of Now we'll talk about some factors that affect human population growth.
Okay. Alrighty. So, and an important thing for you all to remember too is to show your work, to show how you got. I've noticed in the AP classroom they also have points in the system for showing your work, so that you didn't just come up with an answer. To make sure you, and in this case, you want to have your answer in years. Before the last question was, the last section, it was in percentage. This one, your answer is in years.
Now we'll talk about some factors that affect human population growth. And this is a bit of a review from 3.7, so I'm going to run through these fairly quickly. The higher a country's TFR, the faster they're growing because there's more births. Then we have infant mortality and death rate, which have an interesting effect on population growth. They are technically both factors that decrease population growth since they increase death rate. So CDR would be higher and we would have a lower growth rate. But the problem is they're often associated with countries that have high growth rates. And that's because they're often less developed countries with fewer educational opportunities for women and more agrarian economies that depend on child labor for family income. So while death rate and infant mortality rate technically decrease growth rate from just a mathematical standpoint, they're often associated with countries that have extremely high birth rates, or TFR, which then leads to higher growth. Other factors that can increase population growth rate are high immigration level and increased access to clean water, food, and healthcare, since those are things that drive down the death rate. And remember that growth rate is just CBR minus CDR over 10. So if our death rate drops, the growth increases since the difference between births and deaths will grow. Factors that decrease the growth rate are death rate and infant mortality rate. So countries that are really underdeveloped often don't get started growing until their death rate and infant mortality rates start to decline to some degree.
Sink your toes into soft, white sand, splash in the sparkling waters of the Gulf, and revel.
Then we have a bunch of factors that all decrease birth rate. Since decreasing birth rate takes the numerator in our growth rate equation smaller, all of these factors will decrease growth. These are things like development or affluence, so the wealthier a nation gets, the more their birth rate decreases and the lower their growth rate grows. Then we have increased access to educational opportunities for women, delayed age of first child, and postponement of marriage. All of these are factors that will decrease population growth. So our last topic today is to talk about a concept called standard of living. This is an overall measure of the quality of life that the people of a population experience, and it's based on things like wealth, access to necessities like clean water, stable food supply, shelter, and then even comforts like heat, electricity, and access to entertainment. So the first major indicator of standard of living is an economic indicator called gross domestic product, or GDP. This is the value of all the goods and services produced in a country, and we'll often see it expressed on a per capita or per person basis, which just means we're dividing that total value that their economy produces by the number of people in the population. Then we have life expectancy, which is the key indicator of the physical health of a population. And it's just the average age a person in a population will live to. Now, it increases with access to clean water, healthcare, and reliable food sources. It's really important to know that as a general rule, the higher per capita GDP is and the higher life expectancy is in a population, the more developed the nation is, and therefore the lower its population growth as a general rule. So our suggested science skill for practice 3.8 today is describing an environmental problem. So I want you all to see if you can describe one environmental problem associated with a rapidly growing human population, and then propose a solution that government could take to slow population today.
All right, I will put that question in the assignment folder later on, but in the meantime, I have already put assigned 3.8 in the AP classroom for you to work on. So work on, those of you who haven't finished your calculation worksheet, whoops, it doesn't take long for it to time out for me. Those of you who have finished your calculation worksheet, have not finished it, please do that first, and then go ahead and look at the AP classroom. 3.8 has been assigned. Um, module. All right. As always, please read the Canvas module for further backup, for illustrations of the graphs and modern time, and particularly make sure you're always paying attention to and this one's quite long, but make sure that and in sections like this, make sure that you drop down so that you can see different informations provided there. All right, so that's a list, an explanation of all of the density independent factors that would limit a population. So definitely, like I said, click on the arrow so that you can read down. Make sure that you are looking at, write that formula down somewhere. Know the rule of 70 and answer the questions. I should only have one tip for you today is you need to know how to calculate. And again, there's a calculator provided in the AP Classroom program. All right, so I will stop sharing, do attendance. And a couple of you still have 3.6 and 7 in the AP Classroom to do, so please make sure you don't start falling behind. Okay, folks, if you are in a comfortable place to stop, you may do so. You pick up where you left off tomorrow. Stay warm, and I'll see you tomorrow.